Hi, I am a tutor in Uplatz, and today we are going to discuss about what are the embedded firmware engineer will do and what kind of skills are required. Let us first understand what is firmware engineering. Firmware engineering, in analogy to software engineering, covers the specification and design of microprograms, construction techniques, debugging, testing, verification, and maintenance. Here is a look at current state of the art and coming trends. The first step in firmware is specifying what is to be accomplished. There are no widely accepted higher level microprogramming languages. Future work must emphasize the design of machine-independent, efficient, universally accepted higher level language for microprogramming. Verification attempts to prove the absence of errors, testing to discover errors, and debugging to correct errors. Advancing microprogramming techniques will lead to larger microprograms and more widespread use. What is microprogramming? Definitions vary, but one is that microprogramming is the software in read-only control store called firmware that makes one computer, the host machine, respond as if it were another computer, the target machine. Another, it is the level of activity of that converts a programming language into a detailed machine operations that the manufacturer provided. In emulation, the language is low level. In interpretation, it is high level. And again, microprogramming is the program in control store that causes a processor to perform an application. A micro operation performs a small machine operation such as a shift. A set of micro operations occurring in one or two machine cycles forms a micro instruction. A vertical micro instruction controls a single operation such as store or branch and is relatively short, 12 to 24 bits. A horizontal micro instruction controls a number of simultaneous operations and is larger, perhaps 64 bits or more. Basic input-output system is one of the firmware that is very fundamental to any computer or embedded system. In computing, basic input-output system is firmware used to perform hardware initialization during the booting process and to provide runtime services for operating systems and programs. The BIOS firmware comes pre-installed on personal computer systems board, and it is a first software to run when powered on. Board support package. In embedded systems, a board support package is the layer of software containing hardware-specific drivers and other routines that allow a particular operating system, traditionally a real-time operating system or RTOS, to function in a particular hardware environment. A computer or a CPU are integrated with the hardware RTOS itself. Third-party hardware developer who wish to support a particular RTOS must create a BSP that allows that RTOS to run on the platform. In most cases, the RTOS image and license, the BSP containing it, and the hardware are bundled together by the hardware vendor. BSPs are typically customizable, allowing the user to specify which drivers and routines should be included in the build based on their selection of hardware and software options. For instance, a particular single board computer may be paired with any of several graphic cards. In that case, the BSP might include a driver for each graphics card supported. When building the BSP image, the user would specify which graphic driver to include based on the choice of hardware. Some suppliers also provide a root file system, a tool chain for building programs to run on the embedded systems, and utilize utilities to configure this device while running along with the BSP. Many RTOS providers provide templates, BSPs, and developer assistance, and test suite to aid BSP developers in bringing up the RTOS on the new hardware platform. Board package example, the Wind River board support package for the ARM integrated 920T single board computer contains, among other things, the following elements: a config.h file, which defines constants such as RAM size and RAM I address; a make file, which defines binary version of VxWorks ROM images for programming into flash memory; a boot ROM file, which defines the boot line parameters for the board; a target.ref file, which describes board specific information such as switch and jumper settings, interrupt levels, and offset bias; a VxWorks image as well; various C files, including flash mem.c, the device driver for board flash memory, and PCI low map show.c, mapping the file for the PCI bus; prime cells SIO.c, TTY driver; syslib.c, system dependent routine specific to this board; ROM init.s, ROM initialization module for the board, contains entry code for images that start running from ROM. Board support packages. Additionally, the board support package is supposed to perform the following operations: initialize the processor, initialize the bus, initialize the interrupt controller, initialize the clock, initialize the RAM settings, configure the segments, and load and run bootloader from flash. UEFI, or Unified Extensible Firmware Interface, is another firmware. It is placed in between the firmware and the operating system. It is a bridge between the firmware and the operating system. The Unified Extensible Firmware Interface is a specification that defines a software interface between an operating system and a platform firmware. UEFI replaces the legacy basic input-output system BIOS firmware interface originally present in all IBM PC compatible personal computers, with most UEFI firmware implementation providing support for legacy BIOS services. UEFI can support remote diagnostic and repairs of computers even with no operating system installed. Intel developed the original extensible firmware interface specifications. Some of the EFI practices and data formats mirror those of Microsoft Windows. In 2005, UEFI deprecated EFI 1.10, the final release of EFI. The Unified EFI Forum is the industry body that manages the UEFI specification throughout. The firmware stack looks like this. We have at the bottom, we have the chip with various blocks. Next, the kernel space with the various drivers, and the application space with various applications and additional firmware applications. All put together makes the firmware stack. Embedded firmware. Embedded firmware is the flash memory chip that stores specified software running in a chip in an embedded device to control its function. Firmware is embedded systems, fills the same purpose as a ROM, but can be updated more easily for better adaptability to conditions or interconnecting with additional equipment. Hardware makers use embedded firmware to control the functions of various hardware devices and systems, much like a computer's operating system controls the function of software applications. Embedded firmware exists in everything from appliances so simple you might not imagine that they add computer control like toasters to complex tracking systems in missiles. The toaster would likely never need updating, but the tracking system sometimes does. As the complexity of a device increases, it often makes sense to use firmware in case of design errors that an update might correct. Embedded firmware is used to control the limited set functions of hardware devices and systems of greater complexity, but still gives more appliance-like usage instead of a series of terminal commands. Embedded firmware functions are activated by external controls or external actions of the hardware. Embedded firmware and ROM-based embedded software often have communication links to other devices for functionality or to address the need for the device to be adjusted, calibrated, or diagnose or to output log files. It is also through these connections that someone might attempt embedded device hacking. Embedded software varies in complexity as much the devices it is used to control. Although embedded software and embedded firmware are sometimes used synonymously, they are not exactly the same thing. For example, embedded software may run on ROM chips. Also, embedded software is often the only computer code running on a piece of hardware, while firmware can also refer to the chip that houses a computer's UEFI or BIOS, which hands over controls to an OS that in turn launches and controls programs. Duties of a firmware engineer: design and develop firmware for products and services, perform design and code reviews, recommend improvements, perform testing to validate product architecture and design, collaborate with other engineers on technical and design issues, develop firmware algorithms to handle exceptional conditions and errors, install and verify the firmware on embedded system, troubleshoot systems, performance, and functional issues with firmware, execute projects within the defined scope, budget, and timelines, evaluate technical specification for correctness and completeness, prepare reports on project status, issues, risks for management, assist in optimizing firmware to achieve performance standards, provide product support to customers promptly and accurately, ensure in compliance with company policies and procedures, review codes of other engineers, and provide feedbacks. Embedded firmware engineer skills various skills are needed, out of which hardware occupies around 10.6%, Python occupies around 7.1%, C++ around 5.2%, SPI around 5.1%, and software development as 4.9%, and other skills to about 67.1%. We will see in some detail what all the specific things done in each one of these skills. Hardware here is how used in firmware jobs. It is an high demand. Consult with engineering staff to evaluate interface between hardware and software. Develop specifications and performance requests to resolve customer problems. Debug systems hardware boundary scan implementation. Develop design rules that result in second generation hardware designs being defect-free in this area. Projects include generating hardware specification, theory of operation, debug, software integration, and release to manufacturing. Maintain an internal website for documentation of product code and test results for internal engineering development hardware. Spearhead evolutionary architectural change in the firmware to encompass an object-oriented model of the managed hardware. Support hardware and manufacturer groups by implementing an interface to configure test components on controller boards. Design and implement software for rapid modeling and prototyping of hardware equipment under development. Assist in determining hardware incompatibilities with switch, motivating code change and customer communication. Develop interface specification and hardware protocols, making sure that timing specifications are met. Define multiple hardware and software architectures. Develop manual quality assurance testing procedures to ensure code quality and hardware reliability. Design instinctive in system self-test firmware for physical connections between hardware. Participate in research and collaboration with equipment designer and hardware engineers. Coordinate hardware and software engineering development of next generation hardware. Implement telephone call tracking billing system for proprietary call management hardware. Develop documentation for the existing firmware and hardware. Design system architecture for military targeting system hardware. Debug hardware for development and validation purposes. Create Ethernet-based hardware for proprietary security system. Develop digital hardware using hardware description languages. Next skill is the Python, and here is how used in firmware engineering jobs, and it is in high demand. develop new and innovative applications using Python, create multiple automation tools using Python, regular expressions, and make to AS firmware development, expedite testing, and improve release process. Prepare Python and a Unix script to debug and validate the silicon on the evaluation board and test machine. Create FIST test, random instruction test using C and Python scripts based on specifications and schematics. Design, manufacture, test GUI software by PyQt, Python and Qt to do automation PCB testing. Develop and execute software for unit test in Python, Perl, and XML. Target execution of scripts Python developed for testing the requirements. Develop a Python script that was used for parsing the raw data. Develop in C++ using MS Visual Studio with Python scripting. Test existing code using Python. Implement the front end using Web2Py Python web framework, and backend is implemented using Python. Write Python scripts for relay testing of scanners. Develop shared central authentication system in Python for intranet applications, specifically virtualization. Develop, improve, and maintain an powerful internal tool for firmware code simulation from its primary version coded with Python. Acquire skills in C, C++, and in Intel assembly, in general, any assembly language. C++ is the next firmware skill required. It is also in high demand. Craft prototype projects demonstrating C++ template techniques to promote knowledge sharing of generic design methods and test maintainability. Implement local metallic and digital access test algorithms and an object-oriented TR-834 communication interface using C++. Design, implement enhancements using embedded C++ code in Linux environment for legacy mid-server tape automation product. Write C, C++ code for firmware to automation, validate electronic components in assembly manufacturing. Develop customer-specific front-end and back-end code in C++ on enterprise-grade products. Design and implement in C++ data collecting and interpreting software for a prototype medical instrumentation probe for a NIH project. Use C++ as an object-oriented methods to leverage a single code base across multiple sets of functionality, improving maintainability and portability. Develop C++ routines from the ground up to implement textbook algorithms as well as custom algorithms specific to picture quality analysis. Full cycle software firmware development in C, C++ on Visual, DSP++, BFI33 and Linux for Wi-Fi and WiMAX chips. Design and implement embedded firmware for seismic systems using IIR embedded workbench, quantum framework, C++, UML state chart. Design and implement embedded software for time-critical redundant satellite network communication system using C++ on the Intel x86 platform. Utilize TI, DSP, and DaVinci with Linux open source software development for the embedded controller in C and C++. Add and verify embedded C, C++ run on ARM processor to execute change requests and solve customer issues. Develop C++ code for digital cameras and photo printers to locate and whiten teeth in digital photos. Develop various functions used for computation of parameters, display of data in C++ and Oracle. Resolve critical memory leaks due to improper usage of C++ STL containers in system. Develop user interface for vector voltmeter and power monitor application using C++ and Zinc UI interface. Develop firmware for oil service tool using TMS 320F2811 and TMS 320F28335 in C, C++ language. Other DSP processors can also be used. Develop and maintain manufacturing self-test firmware in C, C++ programming language for the enterprise disk drivers. Expand a DLL written in C++ for a fast communication system of high-end data loggers. Next skill required is serial peripheral interface, and it is also in high demand. Here, we design a protocol to provide two-way communications over an SPI interface between USB, ACM, CDC interface, and Wi-Fi radio card. Debug timing noise problems on USB to PC, SBI to MCU, CAN bus networks inside vehicles. Develop firmware from scratch functions SPI mode. Resolve defects within display tool using ARM7 SPI UART and PCI terminal program. Device drivers for SPI interfaces with external flash and transceiver chips. SPI interfaces for real-time clock and NVRAM peripherals. Code for I2C and SPI interface and devices. Design and develop PGA driver over SPI. Include development of I2C and SPI drivers. Design included interfaces using SPI I2C, asynchronous RS-232 and 485, and USB devices and USB OS. Used various interface protocols, CAN, I2C, SPI, serial, RF, etc. Work on SPI, RS-232, USART, UART, Wi-Fi, Bluetooth, low energy. Implement different host interfaces such as RS-232, UART, I2C, SPI, and USB. Include SPI bus, I2C bus, RS-422. Worked on ST, SPI, and CF protocols and maintained I2C, SPI, and UART drivers. Design hardware, firmware interfaces, and written low-level device drivers for PCI Express, DMA, I2C, SPI, and data path ASICs. Produce stable, testable, and maintainable communication software, serial, Ethernet, FSK, SPI, and SCLC. Design generic SPI master-slave modules using Verilog to interface with the rest of the system. Create UART, printf, and SPI flash drivers and port I2C and internal flash drivers from the software code base. Software development is the next skill required for the firmware engineer and is also in high demand. Manage entire software development phase, including project scheduling, coordinating, status meeting, mentoring engineers on daily tasks. Participate in all phases of software development, from high-level design to hardware-software integration and system testing. Prepare and review driver codes, software specifications, software qualifications criteria, and software development documents. Design and successfully complete digital hardware software development for best of its kind optical scanning technology. Design performance monitoring subsystems for RF systems. Initiate changes in process to lower software development costs by 23%. Institute, for an example, institute testing from beginning of software development cycle, enabling detection of bugs before involving full quality assurance team. Work on software development, including the development of FDA compliant software, radiation oncology computer systems as one of the application. Embed software development of sensor-based embedded systems in embedded C for taking dental X-rays is another example. Participate in software development and customer marketing support of the system. Mentor developers and project teams on software development and debug techniques. Evaluate and implement the software development process like RUP. Implement software solutions from those specifications on the silicon. Other GMP procedures for FDA software and development compliance. Let us take an example of airbag software development and how software development is done here. Let software development for Centrion controller and radar monitor, which open greenfield markets for this business. Full cycle embedded software development in C++C on Solaris 9, QNX 4.2. Embedded software development on ARM Cortex based on SoC devices. Develop utility scripts using SCD and ARC to automate the build process in software development. I2C is another high demand skill for firmware engineer. Identify issues and debug using processor probes I2C analyzers, SAS analyzers, PCI analyzers, and other tools. Develop cell phone driver, including audio, I2C, kernel, bootloader, memory manager, and charging. Implement CAN, I2C, and ADC communication between real-time OS and Linux-based microcontroller. Diagnose and resolve I2C, SRIOV, and customer-specific investment and defects. Design and development of FRAM, battery and temperature sensor drivers over I2C. Design dual master I2C protocol to synchronize real-time status between redundant controllers. Enhance PMIC driver and I2C driver for fuel gauge and battery subsystems. Develop I2C driver to read, write, and do from peripherals like EEPROM. Increase factory productivity via I2C driver for setup and diagnostic. Design and development of I2C driver for master and slave. Develop an I2C driver on TI microcontroller and other DSP processor. Design and develop a software I2C model. Implement I2C and MIL 1553 protocol. Design and develop device drivers for USB, I2C, serial UART, Bluetooth. Develop device drivers and BSP for FEC, MII, SCC, Flash, SDRAM, and I2C. Implement I2C communication interface between microcontrollers. Use a microchip PIC to emulate several discrete I2C chips, reducing product cost while enhancing testability and versatility. Contribution created I2C bus recovery algorithm for ANG buses. Architect I2C task design before handing work over to contractor. Configure U-boot intra MFS device tree and port Linux device drivers for I2C, UART, GPIO, and CAN. Next skill required is Linux, which is also in high demand. Re-engineer the custom Linux networking code to ace different 802.11 technology integration. Implement installation process for entertainment product using a stripped down Linux kernel. Present Linux device tree overview and device driver details to ETAN divisions to support their plans and to control lighting over IoT. Here, ETAN is one example of a company. There are other companies which are also can be considered. Set up the build environment for Xloader, U-bootloader, Ubuntu Linux, and for diagnostic in clear case. Develop a sample application for a watchdog timer driver on embedded Linux and Windows for customer release. Lead a project to the prototype use of Android in set-top box environment instead of Linux-based platform. Work with large international team in agile development process, developing firmware for an embedded Linux environment. Participate in giving strategies that aid in porting current system to a fourth generation Linux product. Learn Linux for a new product and assumed responsibility of bringing up U-boot on Power PC Pro. Embed Linux device, bring up executed and documented bring up of a custom TI OMAP based embedded device for TI related applications. Port this to ARM Linux on a Raspberry Pi 2 and added BLE beacon tracking. Develop network, serial, and parallel and mouse drivers for Linux 2.4 kernel. Develop Linux device drivers for an ASIC block that performs JPEG compression and decompression. Assist in debugging of socket-based and Linux-specific bugs on all platforms. Develop a common Unix printing system based on Linux drivers for printers. Produce SNMP, MAB, and agent sub-agent implementing MAB on the Linux controller. Develop utilities and firmware to support root science, internet root assignment applications on Linux. Develop TCL procedures to exercise disk drivers in Windows and Linux. Investigate design of an internet appliances using Linux on an embedded platform. design security system for embedded Linux to prevent theft of online music. Bluetooth is another high demand skill. Modify data transfer support for user requirement for Bluetooth communication. Augment performance of Bluetooth lower stack to support multiple BD addresses and higher density number of connections of mobile units. Test, plan, design, and validation of Bluetooth core and high-speed UART core. Fall prevention system, sensor, Bluetooth control software, and FPGA coding. Write embedded code in C on Texas Instruments CC2541 for Bluetooth low energy application. Develop, implement, test Bluetooth features to support cell phones for high-end headset. Develop embedded Bluetooth LE low energy applications for Noradic NRF51 processor. Maintain the supported Bluetooth profiles, BPP, SPP, and OPP and core stack firmware. Develop frame controller firmware for pressure sensitive fabrics using USB HIDN, Blue Giga WT12 classic Bluetooth interface to Android tablet. Perform requirements analysis, design, and specification of a hands-free Bluetooth application for next generation portable vehicle navigation product. Implement a custom image compression in algorithm in C. Develop custom firmware for Bluetooth low energy modules. Develop mobile iOS applications for Bluetooth low energy. RTOS real-time operating system is another high demand skill needed for firmware engineers. Design, implement enhancements, used embedded C code in RTOS environment for tape automation and tape drive products. Port a proprietary RTOS Motorola 68EC020 and PowerPC processor for use in network communication devices. Develop motor control systems, homespun, non-preemptive cooperative RTOS and communication protocols for the ROV. Debug various critical bugs in the RTOS kernel and contribute bug fixes back to the community. Project include TMS 320F28069 microprocessor and DSP from TA and was programmed in C++ incorporating TA RTOS. Develop code for a wide formatted printer using PSOS RTOS on Intel 80890CA micro. Code is written in C on a nucleus RTOS running on a ARM-based ASIC. Initialize UART, task initialization, ISR, timer, watchdog, and RTOS setup. Design and maintain the printing and slot machine with Intel X-Scale RTOS ARM9 processor. Add many extensions to the RTOS kernel to enhance functionality and diagnostic. Design and development GUI applications using PG Plus and Integrity RTOS. Design RTOS systems and PC applications for embedded applications. Create RTOS with advanced scheduling algorithms. Work with RTOS, design and embedded. Boot RTOS performed system-wide tests. Maintain and customize the RTOS. Embed RTOS, embed OS and proprietary OS. Work extensively with RTOS in a multiprocessor environment. Investigate cellular communication standard and audio embedded system using RTOS C 2000. Modify RTOS MUCOS2 code to support current product that control the new devices. UART, Universal Asynchronous Receiver Transmitter, is another high demand skill for firmware engineer. Develop assembly code for lattice FPGA to read temperature of different cores of the DUT device under test and debug over universal asynchronous receive and transmit. Collaborate with senior architects and firmware leads to design and implement various firmware modules such as UART and timer. Create USB to serial UART translation abstraction layer. create and configure the process for UART and modem, develop Modbus communication link utilizing on-chip UART and DMA, implement UART-based debugging and logging method, implement auto-detect baud rate for UART, develop drivers for ADC, GPIO, timer, UART, and application programs for MSP430 family of microcontrollers from TI, update keyboard, LCD display, dual UART, and dot matrix drivers for state-of-the-art replacements, design a PM bus over UART gateway on weaker power step system using Cortex Micro MO ARM processor. Firmware is another skill needed by the firmware engineer. Modify base firmware according to customer specific application for both nuclear safety related and non-safety related application. Design and implement firmware to PC interface for servo system analysis, data mining and measurement capability, support and mentor junior engineers in design and development of firmware involving multiple different projects, review test scripts of verification validation team to ensure complete coverage of firmware requirements, manage firmware section of functional requirements specification and high-level design document, design and develop a cycle optimized dynamic memory manager in firmware, implement firmware enhancement to create single output mechanism, simplifying usability, implement modifications in firmware for feedback and fault manager component, develop firmware and operating systems for laboratory battery test system, develop firmware for sophisticated power line communication products, define and incorporate quality processes for firmware development team, determine application-specific firmware requirements from project performance specifications, develop communications firmware for a remote SPA controller, perform firmware validation testing and code verification, design and debug stepper motor monitoring firmware, power supply and fan management firmware, startup firmware code to set up PLL memory access module in assembly language. Advanced development, develop firmware for highly evolved scientific water analysis apparatus, pH, conductivity, dissolved oxygen meter. Collaborate with servo engineers to debug and test servo algorithms and measurements as well as firmware integration with the firmware engineers. Design and implement reel-to-reel and track following servo control firmware interpret architect for 4 generations of LTO tape drive. Work in sustaining engineering to support add new firmware functionality for the Red Epic 4K and Dragon 6K cameras. GIT, the version control system, is another important skill needed for a firmware engineer. Use of version control system GIT, use Tectonics logic analyzer, ITP JTAG tool, VISA, Lackmore debugger, JIT version manager, and HSD tracking tools. Participate in the development groups transition from SVN to Git and Act2. Use the SVN and Git configuration management tools. Develop in a distributed cloud environment using JIT, Gerrit, CMake, Jerkins, and TeamForge collaborator for software management. Implement configuration management plan for development projects using ClearCase, PVCS, PCMS, JIT, and other configuration management tools. Develop application firmware and drivers for a MSP 430 handheld product incorporating IRDA, USB, SMS, and GPRS interfaces. Port device mosaic to a proprietary platform. Develop USB interface functionality for the set-top boxes. Expand communication libraries to include USB and TCP/IP, including wireless support modules. Develop a driver for USB controller and transceiver. Design USB-based data link to PC. Design hardware and firmware from PCMCIA to USB post controller. Employ various USB drivers such as CDC, MSC, and HID, which supports drag and drop programming and device enumeration. create Windows asynchronous USB driver for cast AR system and rework USB device firmware. Develop and design full test bed platform for USB to CF plus ATA adapter. Out of business R5200 USB to digital IO module. Also is carried out. Implement new C drivers for UART serial over USB flash based on PI example code. Prepare testing softwares for XC licensed USB module. Utilize USB 3.0 and Aptina sensors. Design and implement server on NET plus OS for data acquisition. Develop PC side drivers for the USB and Ethernet interfacing with QDAC. RF radio frequency is another firmware engineer's skill needed, which is also in high demand. Company developed high power RF generators and high power RF impedance managing networks used in plasma etching. Design and debug a lattice PLD based 4x8 position RF coaxial switch controlled via the PC parallel port. Implement a proprietary protocol for a link driver to communicate with RF repeaters and devices. Adjust the RF powers to enable our products to pass the FCC certification. Develop a routine that adds RF device to the remote network. Develop support for multiple remotes on the same RF extender. SoC, system on chip, is in high demand. It's the average demand for a firmware engineer. Collaborate with validation, design, and hardware development teams and participate in SoC bring-up and validation activities. Validate SoC low power modes and domains by slowing clocks, shutting clocks, and shutting down power domains. Analyze field applications rejected SoC based on 2 DSP and 051 coming from ST customer BOS. Conduct extensive debugging and verification for the next generation SoC and board hardware. Design, develop, and maintain manual and automated power tests from ARM SoC. Experience with the ARM SoC for automotive applications. Develop data transition protocol between PC and CNOS and in-house design SoC system using LPT port. Implement unit test framework for firmware modules. Develop and support firmware for SoC based on ARC core. Perform SoC bring-up and troubleshoot issues related to DDR high-speed interface. Develop SoC bring-up firmware for multiple generation of SoCs. Yeah, thank you.